So today we're going to go over how to start our asynchronous lesson number 2. What I'm going to be doing is going over these two as examples and then attaching the video for you. Then what I'd like you to do is after you watch the examples is to go ahead and do these practice problems. Now, you can attach your work here or you could submit the work on a separate piece of binder paper. Now make sure that your separate piece of binder paper has at least a sketch of the graph and the x values that we're looking at. So these are the types of problems you'll be doing today. There are 6, and I'll be going over 2 examples with you. Cool. So what I'm going to be doing is transitioning to my doc cam just to better show you all using, division signs and things like that. It's a little bit more difficult if I'm using Google Docs. So first thing is, again, you do not need to have this printed out. This is just for me to help show you how to do these 2 example problems. So we're going to be finding average rate of changes in graphs and also in given a function. Sometimes you can be given a table or even a situation. So for example, a situation was when you were asked to find the average rate of change of a heart rate. So how many beats per minute is your heart going? So again, this is useful in the real world because sometimes if your average heart rate is below a certain amount, it's actually dangerous. So this is when average rates come up in the real world. But let's go ahead and apply average rates to either a function, function graph, or a function equation. So let's begin. So given the graph below here, we're going to be finding the average rate of change between x equals -2 and x equals 0. So let me just go ahead and find where -2 is right here, and I'm going to go up to my graph and put a dot there. I'm going to go ahead and also label my point. So it looks like it's -2, 4. And then the next one is x equals, so I got this one. At x equals 0, well, that's already kind of labeled for us. It's just 0, 0. Okay, now that I have the 2 coordinate points of interest, I'm going to go ahead and just rewrite them here on the side. So I have -2, 4, and then I have 0, 0. Now, to find the average rate of change, for example, when you have velocity, the average rate of change when it comes to velocity is total distance over time. The average heart rate is going to be total number of heartbeats per minute, right? So then what would be the average rate of change in a graph? So usually the average rate of change in a graph is the change in y over the change in x. That is the average rate of change in a graph. So some of you might recognize that as the slope formula. Usually slopes are found in line graphs, right? But to find the average rate of change between 2 points, what you do is find the slope between the 2 points. And what that gives you is, in general, the movement or the change between the 2 points, and that gives you an average. So let's go ahead and find basically the slope of these 2 points, and that will give us the average rate of change. One thing I want to point out is notice that this is it doesn't have like an actual like feet, meters, or anything like that. This is actually a very general type of function. It doesn't have units is what I'm trying to say. So we don't have to worry about units for this. So the next thing I'm going to do is I'm going to label my points. I'm going to title this as x1, y1, x2, y2. So if you remember the slope formula, it's also known as m equals y2 minus y1 all over x2 minus x1. After you have this, you're going to go ahead and substitute. So let's do this. My average rate of change, or you could title it as m if you want, because in general what we are finding is kind of slopes between 2 points, and that's going to give us our average rate of change. So y2 is 0 minus, and then y1 is 4. x2 is 0 minus, and then x1 is -2. Y'all see what I just did down here? Because my x1 was -2, I had to minus -2. So be careful with your signs. 0 minus 4 is going to be -4 all over. 0 minus -2, if y'all remember, minus becomes a positive. So that's going to be 0 plus 2. So we have negative 4 divided by 2. Let's simplify that. Our answer is going to be for this first one, because I'm running out of space, is going to be negative 2 as my average rate of change. So remember, because this is like a generic type of function, I don't have units, so I don't have to write, like, for example, meters per second or beats per second, like in a heartbeat. So this is my average rate of change for this first example. So let me go over the steps again. So to find the average rate of change in the graph, that's change in y over change in x. Change in y over change in x is your slope formula. And what you're doing is once you have your two coordinate points, you write them down, you label them, and then you substitute into the slope formula to get your answer and you simplify. So that's how you do it with a graph. Now let's go ahead and see, what if we don't have a graph and we just have a function? Now, there's different ways you can go about this. You could use Desmos and identify the 2 points like that, like we did in this one. Or you could do this method, which is basically plug and chug. All right, so find the average rate of change of this function between x equals 1 and x equals 2. So what we have is our input values. All we need now is basically our output values, because what we have here is going to be 1 comma, and then we don't know what that y value is, 2 comma, and we don't know what that second y value is. See, this is my first one, and then this is my second. So we just need to find the outputs. Now we can find the outputs because we have a function. If we plug in an input into our function, we get an output. So let's do that. So for this first coordinate points, we're going to do f of 1. I'm going to plug in 1 into my function right here. So 1 squared plus 3. 1 squared, that's 1 times 1. That's just 1. Plus 3, I get 4. Great. My second point is 2. So I'm going to plug in 2 into my function. 2 squared, that's 2 times 2. That's 4. Plus 3, that's 7. Great. So now we have our two coordinate points just like we had here. So again, to find the average rate of change, all we got to do is put the coordinate points into the slope formula and we get our average rate. So let's go ahead and do that. So we're going to label this as x1, y1, x2, y2. Let's do this. Let's find the average rate of change between these 2 points. So y2 is 7 minus y1 is 4. x2 is 2 minus x1, which is 1. 7 minus 4 is 3. 2 minus 1 is 1. 3 divided by 1, well, that's just 3. Because we don't have units, I don't put units. Usually, when you're finding the average rate of something, so rate means it's a unit that has like something per something, like meters per second, feet per second. You know, there's a time change that's happening. It's a rate. But again, because we don't have units, this is generic. All you need to do is write the number as your answer for these problems. So there you go. Great. So again, these are the examples below. Your assignment is basically very related to what we did. So a bunch of the first problems are going to be just like the first sample I did, and then after that it's going to be just like the equation one that I just did after that. So you should be very much prepared to do this assignment to the best of your ability. My expectation is you show your work and come in the office hours if you need some extra one-on-one support on these. So these are the ones that you would do like the second sample. All right, everybody. So good luck. Thank you for watching this.